This is the presentation that I gave at the Quest for Quality conference in Dublin, Ireland. AI is eating software, using AI to write tests. So Mark Andreessen wrote an article about why software is eating the world. This is back in 2011, and essentially pointing to the fact that software was automating pretty much every industry. And so Mark contended that in the future, every company will become a software company in the sense that every company will need to use software in order to differentiate and be successful. The irony of this is that software has eaten almost everything except writing software itself. Software is the only industry that has not been automated by software. Jensen Huang, who's the CEO of NVIDIA, contends that AI is going to eat software. And what he means by that is essentially that AI techniques are able to produce programs and solve problems that human programmers have been unable to tackle, in some cases for over 30 years. And essentially what we see is that AI is eating code from all different angles. And Jensen Huang is talking about machine learning AI algorithms that you have there on the left. So for certain tasks, things like image recognition, AI algorithms are much, much better than algorithms written by computer programmers. And for image recognition, in fact, computers are now more accurate even than human identifiers, so more accurate than humans when it comes to identifying images. At the top end, you also have new low-code, no-code AI platforms. So things like H2O, Data Robot are in this space. And so essentially they are reducing the amount of code that is necessary to build those machine learning models. And then in the testing world, you have things like Testcraft and Mabel, essentially using artificial intelligence to emulate humans. So, testing that looks like a human is using the product. And then coming up from the bottom, things like Tab9, which is AI-based autocomplete. Microsoft also has introduced a similar technology for Visual Studio Code now. And then things like Diffblue, where we're writing tests using AI. And so I'm going to talk about what Goldman Sachs has been doing with this and what that looks like. So Goldman Sachs has been using AI to write Java unit tests. And their purpose there is to accelerate their software development process, improve quality, and facilitate agile adoption. So what does this look like? So what I'm showing on this screen is an example of a test on the right-hand side that has been written by Diffblue AI. And on the left-hand side, you can see the original code. So the tool takes the original code, analyzes it, and then uses that analysis to write unit tests. So on the left-hand side, this is a noughts and crosses or tic-tac-toe game playing code. And this method here checks to see if somebody has won the game. And so we can see on the left-hand side, beginning at line 64, here's the logic that checks to see if a player has won by filling a column. On the right-hand side, you can see the test that was written by Diffblue Cover in order to exercise this path. And essentially, it's arranged in 3 sections. The arrange section itself puts together the data that is going to be fed in, the inputs that are going to go into the method. And you can see here, it's building an array of integers that represent the board. It creates a board object from those. And you can see that player 2 has won in this particular example. And then it actually runs the method itself and checks the result and asserts that in this case, player 2 should have won the game. And so the AI goes through each of the methods, and for a particular path of execution, it will generate a test to take you through that path and assert that you have the correct result. In Goldman Sachs, real challenges is that they know that there's a relationship between the use of automatic testing and high software delivery performance. And this is something that the authors of the Accelerate book were able to demonstrate. Unfortunately, a lot of Goldman Sachs software was written before unit testing was an established best practice. And so they have a backlog of tests to be written and maintained versus their software delivery goals. So at Goldman, they used this technique of AI to write unit tests, and they've been able to increase their coverage to go from 36 to 72%. And Goldman estimates that it is 10 times faster than manual coding. So the comparison there for a human, let's say it takes 30 minutes to write a test, and the human works 6 hours a day. So in one specific example, we were able to write about 3,200 tests. This was an overnight run, about 8 hours to generate all of those tests. And Goldman estimates that would have taken 268 developer days. So you can see that this technique is much, much faster than the manual alternative. And so for organizations who are looking to adopt this kind of approach very quickly, having AI write the tests and then also maintain them is very attractive. So here's how this currently works in the Diffblue product. Essentially, you have the input Java program, which we analyze. So it's a blend of static and dynamic analysis. And from that, we get a code behavior model. And essentially, we are conducting an AI-guided search through that model, both for control flow and data flow. That gives us a testing strategy, which we can then use to synthesize Java code that will exercise those different paths and feed in the correct inputs and check for the correct outputs. And so that goes into the tests that are generated. At Goldman, the deployment architecture is based on Kubernetes, so everything runs in containers so that we can scale out the application of this product. It's memory bound, and so by adding additional instances, you can essentially parallelize the generation of tests. Current challenges with this kind of approach, well understood problems in reachability analysis. So one-way functions, for example, for hashing used in cryptography, and in other applications, the entire purpose in cryptography is that it's very difficult. It takes infinite amount of time to reverse the function. And so we have not solved sort of magic computer science problems here. So what we can assert on the other side of a one-way function is basically that it is not null, but since we can't reverse it, we can't figure out what the correct input should be. And in general, polynomial reachability problems are challenging. So high complexity code when reachability analysis becomes polynomial. But on the other hand, this is a good indicator that that is a method that should be refactored. If it has that kind of complexity in it, then it is a good candidate for refactoring. So the ultimate goal here is that you can get a set of unit tests that can run very quickly right after a commit. And so this kind of technology is really good for generating that kind of test, unit tests. So these are designed to be simple. They should run quickly. They should find regressions that are part of the code. They should fail when there's a regression. And they can be used very early on in the process in order to get feedback to the developers. And so essentially, these are imperfect tests, right? And from Martin Fowler's quote there from his 2006 canonical paper about continuous integration, imperfect tests run frequently and much better than perfect tests that are never written at all. So you could think of this AI as writing imperfect tests, if you like. And so a brief summary, AI is eating software in lots of different ways, top down, bottom up, algorithmic, and in test automation. AI written tests are one example of that, sort of bottoms up. And they're about 10 times faster in the case of Goldman than using a human software developer. And they run early, they run quickly, and they spot basic functional errors. And so it's quick feedback to the developer as they commit code. AI-based user emulation is better for functional tests. There's been a lot of work done around emulating humans, making it look like a human user sitting in front of an application. And for applications that have a user interface like a browser or something else, then that is much better for functional tests. This kind of testing is really about unit testing, and it happens earlier on in the CI or development cycle. Thanks very much for your time and attention. Hope you enjoyed the presentation.